Welcome to the series where we do exercises on LangChain, OpenAI, and Python. This is a big one. In this exercise, we build a QA bot based on custom user data in a PDF format. But in this video, we break everything down into the following steps. In the first step, we will cover OpenAI embedding basics. In the second step, we load and prepare the PDF data using vector embeddings and ChromaDB. In step number 3, we perform similarity search on that vector data. And in step number 4, we perform question and answer sessions with the AI on that vector data using a LangChain QA retriever. So let's get started. All right, so this is where we're going to perform the exercise. And these are the 4 steps we're going to follow here. So let's get started with the required installations. As you can see, with the regular libraries that we normally bring in, additionally, we're bringing in ChromaDB and PyPDF so that we can handle PDF document loading. And this is the vector database we're going to need for our vector embeddings. Once this is done, I'll be right back. All right, so looks like our installation is done. So now let's move to the key setup. I kept it simple. I brought in OS and setting up the environment variable OpenAI API key. And this is the one that LangChain looks for when it's looking for your API key. So all you have to do is replace this string with your API key and hit this button, and your API key will be set into your environment variable. That said, let's go to the step 1. All right. This is the step where we do vector embeddings, basically cover the basics, and perform a similarity search manually on those embeddings using a Python library called NumPy, which is basically a library that is used for working with arrays. It has lots of helpful functions that we can use. So in here, we are bringing in the OpenAI embeddings from LangChain_OpenAI. And now we are instantiating this class to create this object, embeddings_obj. And this is what we're going to use to convert this sample text into embeddings. So let's go on and make the embeddings. So this is the method embed query that we're going to use and pass this text1, text2, and text3 into them to create embedding 1, 2, and 3. So let's look at what embedding 1 it looks like. Let's run it. All right, so this output doesn't really do it justice, so I create a separate file so that I can show it to you properly. This is what our embedding 1 actually looks like. This is a vector representation of our embedding 1, which is basically based on text 1, and this is the text. Astronomy is a great subject to study. So basically what's happening is that OpenAI embedding algorithm is creating this vector representation of this sentence or text by adding 1536 dimensions to it. How this is actually done, we don't really know, but to describe what dimensions are, I have something for you. So let's say we take these 2 words, apple and grape, and add 4 dimensions to them. And the dimensions would be, let's say, redness, sweetness, tartness, and crunchiness. And then we insert them into a vector database or plot them into a graph. And this is what they're going to look like. When we try to perform similarity search based on these dimensions, apple and grape are going to be very close together. But cucumber, on the other hand, will be farther away. And that's how similarity searches are done based on vector representation of text. That said, now we will perform similarity search based on this vector representation. Let's get to it. All right, so at this point, we're going to perform a manual similarity search using this library NumPy. We're bringing that in as NP, that's the object, and we are going to implement that like this, np dot, implement that dot function that will bring us the similarity between these 2 embeds, 1 and 2, and give us a big decimal number into this similarity variable, and we're going to multiply that with 100 to get a percentage out of it, so that we can easily visualize the similarity in percentage. And we have 3 of them right here. Embed 1 versus 2, 1 versus 3, and 2 versus 3. And let's run it. All right. So now look, when we compare astronomy is a great subject with cats are friendly, we're getting a low percentage. But when we are comparing text 1 with 3, which are very similar because they're all talking about 2 subjects, right? And scientific subjects, we get the highest output of similarity, which is 80%. And similarly, when we do compare 2 and 3, once again, with cat with biology, we're getting a low similarity search, right? Let's try it with another set of text. Here, we're simplifying this even more by using just simple words, dogs, cats, and math. So let's rerun this. Look at that. When we compare 1 and 2, which is dog and cat, we get 91%. But when we compare with cat with math or dogs with math, like these other 2, we get very low percentage. So this is how basically the similarity searches happen when we use, let's say, databases like ChromaDB or in something like that. And based on that, we will be retrieving documents from our vector databases and then send them to the AI so that it can find the best answer for us. That being said, let's move to the next step, where we're going to be loading the PDF, create the embeddings, and the vector database. All right, so we are officially in step number 2 and time to get serious. So here, I'm bringing in the OpenAI embeddings class from LangChain.embeddings and creating an object by instantiating this class. Then I'm loading up PyPDF loader from LangChain.documentLoaders. Using this class, I'm creating an object loader, and as an argument, I'm passing a local file name, which is mostlinkedinprofile.pdf. In case you're wondering where that is, this is right here. This is just a simple drag and drop job. And this is what it looks like. It's a pretty long one. That said, let's go. So once the loader is created, then we are invoking the method .load to pull in all the text from this PDF and dumping into this docs variable. And here I'm bringing in prettyprint library so that the output looks nice. So let's see what the docs hold. Let me run this. All right. So this is all the text from that PDF. It's all loaded up in a list with the PyPDF loader class. And that being done, let's move to the next step where we split up the document into smaller chunks so that we can get it ready to create vector embeddings. All right, so this time I'm bringing in recursive character text splitter from LangChain.TextSplitter. And by instantiating this class, I'm creating this text splitter object so that we can invoke the methods. And when we are instantiating it, we are passing these 2 variables, the chunk size to 1000 and chunk overlap to 50, to letting it know how to break them down into chunks. And this number combination, 1000 and 50, has been working out best for me. I mean, you can sometimes go down to 20 on this one, but that doesn't matter. And also, I always choose the recursive splitter over any other splitters because this is the smart one, because when it splits everything into chunks, it always maintains the semantic meaning, by which I mean it notices the paragraph and word, etc., when it's building its chunks. And that said, now let's invoke this method, textsplitter.split documents, and pass that docs that we created here. And let's look at what our splits are looking like. So let's invoke this or run it. And here it is. And if you notice, now this list contains a whole bunch of extra ones. And that said, let's move to the next step where we take those chunks and create our vector embeddings and put them into a Chroma database. All right, so this time I'm bringing in Chroma from LangChain.VectorStores, and using this class, I'm creating this vector store object, and I'm passing these arguments. As documents, I'm sending the splits that we created right here, and as the embedding algorithm object, we're sending this embeddings that we created up here using OpenAI embeddings, so that once we take these splits, the documents, we can use this embeddings object to convert them into vectors using the OpenAI algorithm. And last but not least, the persist directory, we're giving it a location of a folder where to write the database in our local file system. And once this object is created, then we're invoking this method by using vectorstore.persist. And this is where it will finally create and write the database on our local file system. And once all said and done, we are printing the vectorstore.collection to get some information on the database, making sure that it actually happens. That being said, let me run it. All right. So this is the information on our vector database that we just created, and this is the location. And that's what it looks like. That said, let's move to our next step where we perform similarity search on this Chroma database. All right, so at this step, we're going to perform the similarity search. So for here, I am actually created a bunch of queries to, the questions to ask. Basically, these are the ones we're going to use to query the vector database. And here I'm bringing in that vector store that we just created, this object, right? So in here, that vector store, and I'm invoking the method .similarity search. And as an argument, I'm passing this query. So let's see what comes up. All right. So here we get a list of documents. But in here, as you can see, the actual content is inside the page underscore content. So I'm going to go ahead and disable this one and bring this one online where we actually get to see the content. So let me see. Boom, there you go. So it went out there. I asked the starting date, but it got a bunch of stuff in here. Please remember, at this point, there is no AI involved. Basically, it's performing the similarity search just like we did using NumPy, right? So if you look at here, we go back to the document and we can actually find AT&T right there. See, right here, and all this detail. So it just went ahead and brought in this detail right here. So if we're asking starting date and we're searching and we're getting a similarity search result as this, and let's say if we send this question and this result to the AI, how easily you think the AI will pick up on this, right? It can easily answer us. But at this point, we're not getting the answer. We're just getting the similarity search result from the vector database. So let me try one more time. Let's say ask about Cyberize group, right? Oh, there you go. What did I do? See, this time it's a little bit larger because it's looking for more stuff. Because I asked it, what did I do? It's the other question, the starting date was a little bit more specific compared to this one, right? So now that we have seen, we can generate this kind of similarity search results. Let's move to the actual Q&A setup where we use a LangChain QA retriever to perform this question and answer session with the AI. And this part, the AI model will be involved. Let's get to it. All right, finally we are here. This is the most fun step. This is where we actually create the data retrieval. And as you can see right here, for the first time, I'm bringing in Chat OpenAI and creating my model with GPT 3.5 Turbo and giving it a temperature of 0.5. Once that's done, we're creating a retriever object using this Chroma DB, this Chroma class, we're passing it the persistent directory, basically the location of the ChromaDB, which is this guy right here. And as an embedding function argument, we are sending the embeddings, which we created a long time back, up here using OpenAI embeddings. Now, with this object, we can finally gonna create a retriever that will perform the similarity search on this ChromaDB depending on our query. So let's get that done. All right, so this is our retriever object, which is my retriever, and I'm using the vector store retriever dot as retriever and sending a search arguments saying k:3, which means bring me 3 similar documents. So basically with this, what we're telling Chroma is that whatever query we do get, based on that, you will go in there and fetch me 3 similar documents, just like you did right here. This time we're actually, limiting it. Here we did not say how many we want. We just send our query and get the answer, however many document it can bring, it brought. But this time we are asking for specifically 3 documents and creating this retriever object. Now it is time for us to create the Q&A chain, where we will, send all of the above to compile ourselves a QA chain that will finally send the request to OpenAI. Let's do it. All right, we are almost 95% done, I promise. And at this point, I'm bringing in retrieval QA from LangChain.chains. And with that, we are creating a QA chain by instantiating this class retrieval QA and sending it all these argument, which compiles all of the above into one. And once we create this chain, we can invoke that, and that will finally send the request to the AI. So here, as LLM, I'm sending my model that we just created here, and then chain type is equal stuff. It's basically, we're getting all the data, search results, and stuffing it into it. That's why it's called stuff. If you want to know more, please refer to the LangChain docs. And then comes the retriever, and we just created this retriever using a ChromaDB. My retriever, we're passing that, and I'm setting verbose equals true, because that will give us some extra steps so that we can, use that for troubleshooting. And then last but not least, it's return source documents to true so that we get metadata with our answer. And that being done, I'm just gonna skip this step and go straight to it just so that I can show you the results of what we have done so far. Okay, so I'm just gonna set up a query. What is the starting date at AT&T? And now that we have our QA chain, I'm just gonna do a QA chain dot invoke and send my query there and print out the LLM response, right? So let's run it. All right. See, because of verbose true, we're actually seeing this step, like it actually entering the QA chain and then finish the chain and send us the result. First the query, what I just asked, and then result, the answer, exactly what I wanted, and also source documents, right? So it's kind of like broken up. So I'm going to make a little bit of change here. I'm just going to clean it up a little bit using verbose false, so that we don't need this extra information. And I'm going to bring in this and specifically target the result instead of seeing the whole thing. So let's see if I rerun it, what happens. Perfect. Exact result we were looking for. And now let me bring in a few more questions. Okay, so I'm going to go ahead and try another question here. What did I do in Cyberize group, right? So let me run that. All right. So a whole bunch of responsibilities here. Okay. So pretty much if we go back and these details it's showing. So now next we're gonna go ahead and bring this guy in. How long did I work at Deepcast? Let me run that. Okay, so 1 year, 2 months. Let me go find Deepcast. Exactly 1 year, 2 months. And now the last question. How long did I work at HP? Oh, 1 year, 6 months. And let's go to HP. Where is it? Where is it? Right here. 1 year, 6 months. Perfect. And with that, let me conclude the hands-on exercise number 6, where we built PDF QA bot using LangChain, OpenAI, and Python. Thanks for watching.